Alright, in this video I'm going to be going over the assignment 39 notes. And in fact, you might be wondering, why are we doing assignment 39? Because we already did assignment 39 and you are correct. However, to get ourselves on track with the other AIM courses, we're going to call this one 39B. So the homework assignment in your book you want to do is assignment 39, but go ahead and label it 39B because we've already done 139. Okay, so let's get started here. So in this section, we're going to talk more about exponents. We're going to go further than we went into further detail than what we did before. So first of all, we've got some properties of exponents that you should recall. So first one is the product rule. When we multiply two powers of a here, think about what we do with the exponents, and that would be add. So we add the exponents. So that's the product rule. Then we have the power rule. We have a power to a power, and that's where we multiply the exponents. And then finally we have the quotient rule, where we have a to the sixth divided by a squared. So we're dividing two powers. That's why we call this the quotient rule. And notice if we when we multiply powers of a, we add the exponents. It makes sense that in this case, since we're dividing powers of a, we'll do the opposite and subtract. And so you get a to the 6 minus 2 power, which is a to the fourth. So these are our three key properties of exponents. We also talked about a couple of others that I'll mention in a minute, but let's go ahead and start using these. So on the first problem here, you're just adding the exponents. You get z to the 14th. X to the 7th over x cubed, you're going to use the quotient rule and subtract the exponents. You get x to the 4th. Now I didn't mention this, but I wanted to remind you that anything to the 0 power is 1 and not 0. And so if we have 2y to the 0 power, notice my base is everything inside the parentheses, and any base to the 0 power is 1. For negative 4 times y to the 0 power, notice this time your base is only the y because there's no parentheses here. And so this is negative 4 times y to the 0 power, but y to the 0 power is 1, so this becomes negative 4 times 1, which is negative 4. Now there's two other properties I haven't mentioned that we discussed previously. They're very similar. Notice if we have a times b raised to the n power, that's equal to a to the n times b to the n. So basically we just apply the exponent to each of the bases a and b. And in a similar way we can do the same with fractions. If you have a over b to the nth power, you just take the nth power of your numerator over the nth power of the denominator. So we're going to use these two properties on the next two problems. So here we have negative 3a cubed squared, so we're going to square the negative 3, and we're going to square the a cubed. So negative 3 squared is 9, and then here we have a power to a power, so we're going to multiply the exponents, and we get 9a to the 6th. So similarly, on the next problem we have, on this one here, we have a cubed, and then b squared cubed, so that's a power to a power, so we multiply the exponents, we get b to the 6th. And then we have 2 to the 3rd power, or 2 cubed, in the denominator, and then c to the 4th power raised to the 3rd power, so power to a power, that's going to be c to the 12th. And 2 to the 3rd power is 8, so we can rewrite this, and that's our final answer there. Alright, let's talk now about negative exponents. Notice it says here your answer will never contain a negative exponent. So negative exponents are not allowed in your final answer. So if you look at this first problem here, a squared over a to the 4th, we're going to want to use the quotient rule, and we subtract our exponents, and we get a to the negative 2 power. But what does a to the negative 2 power really mean? Well, let's go the other side, and let's write what a squared over a to the 4th means. It means a times itself, and then 4a's multiplied in the denominator. Excuse me. And so we can do some canceling here. Divide by a again. You're going to have 1 times 1 in the numerator, which is 1, And notice you're left with a times 1 or a squared in the denominator. So we can see that a to the negative 2 power is equal to 1 over a squared. So it turns out the rule is a to the negative n power is equal to 1 over a to the positive n power. I always say, let's see, I'm getting ahead of myself here. That if you have a negative exponent, I say negative exponents lead to reciprocals. So let me write that down here. Negative exponents lead to reciprocals. Not negative numbers. I think that's kind of odd because we're used to thinking in negative in terms of sign, but notice for the first problem there we had a to the negative 2 power, which is 1 over a squared, and that's not a negative number. In fact, we would call a squared and 1 over a squared reciprocals. So negative exponents lead to reciprocals. It's 1 over the same base to the positive power. So on number 1 here, we have 5 to the negative 2, so we're going to write that as 1 over 5 to the positive 2. And of course 5 squared is 25, so we get 1 over 25. So I want you to notice 5 squared is 25. 5 to the negative 2 is 1 over 25, the reciprocal of 25. On number 2, we're going to do the same thing. It's going to be 1 over negative 3, my base, to the positive 3 power. And negative 3 times negative 3 times negative 3, we're going to get 1 over negative 27. We normally don't leave a negative in the denominator. Let's move it out front. So the answer is negative 1 over 27. Oh, I just realized I wrote in a place that I'm going to be needing space. So let's see, here's the thing. It turns out that if you have a problem like a to the negative 1 times b to the negative 2 over c to the negative 3, anytime we have a negative exponent in the numerator, we know like a to the negative 1, that's just 1 over a to the positive 1. B to the negative 2 is 1 over b to the positive 2. So there's another way we can think of this. We're just going to move the a to the bottom, and we're going to change the sign of the exponent to a positive 1. Similarly, b squared, or b to the negative 2, is going to move to the denominator. It'll be b squared. And then notice, now the same thing's going to happen when you have a negative exponent in the denominator. We're going to move the base up, whoops, and this will become c to the positive 3 power. So really, when you have a base with a negative exponent, all you have to do is move that base up or down in the fraction, or you can create a fraction and change the sign of your exponent. So really on number 3, all we need to do is move that x to the negative 6. We're going to move that base of x downstairs into the denominator, and we're going to get x to the 6th power in our denominator. Now I'm going to go ahead and hit this, and it's going to make a mess here. So let me just fix that real quick. All right, so in this case, I still have to clean that up. All right. There we go. No, we're not quite done yet. All right. So notice on number 3, all I have to do is move my x to the denominator, and it becomes x to the positive 6th power. So this makes it pretty easy when you're dealing with negative exponents. You can just move your base up or down and change the sign of the exponent. So on number 4, we're going to want to move the 4 to the negative 2 to the numerator. It'll be 4 to the positive 2. Now you could write that over 1. Actually, let me fix this. So 4 to the positive 2, you could write that over 1, but it's still the same. And 4 squared would be 16. All right, let's move on to the next problem. So in number 5, we're just going to be moving our bases up or down. Let's move the 7 down our base of 7 and the 2 becomes positive, and let's move our base of 4 up and the 3 becomes positive. Now be careful here, you can't use the quotient rule because you don't have the same bases, but you can take 4 cubed, which is 64, and 7 squared is 49, and so that's your final answer. Now there's another property I should show you that deals with fractions. If you have a fraction like a over b to the negative n power, that's equal to b over a to the positive n power. Again, it goes back to this reciprocal idea. Notice I just flipped the fraction and changed the sign of the exponent. So this is really handy when you have fractions with negative exponents. So on number 6, I'm going to flip the fraction there. I get 4/3 to the positive 2 power, and now we'll use the extended power rule. We'll square the 4 and square the 3, and we're going to get 16 over 9. Now number 7, just be careful with those two negatives. The negative out in front deals with sign. It's really like negative 1 times 4 to the negative 4 power. And of course the other negative 4, that negative is indicating that we have a negative exponent. So I'm going to leave the negative out front, and I remember that 4 to the negative 4 power is 1 over 4 to the positive 4 power. Again, keep the negative out front. I'm sorry, what I was trying to say there is my base is 4, not negative 4. And so we're going to leave the negative out front, but 4 to the negative 4 power is 1 over 4 to the 4th power. And so if you multiply 4 4s, you get 256. So the final answer is negative 1 over 256. So you can see in a problem like this, you might be tempted to think things like 2 negatives make a positive, but in this case, that's not true. And you always have to be careful with statements like that because they may not always apply. All right, number 8. Looks kind of complicated, but if you look inside the parentheses, it looks like there's some stuff we could simplify. We could just take everything to the negative 2 power, but it's going to be a lot easier if we simplify inside the parentheses first, which we can easily do. 10 divide 5, that's going to give me 2. X to the negative 3 over x to the 6th, well, we're just going to use the quotient rule. Now be careful when you subtract the exponents. This is negative 3 minus 6, which gives you negative 9, so this is x to the negative 9. And then we have y to the 5th over y to the negative 2 power, 5 minus negative 2. Be careful there, we're going to get 7. And so when we simplify inside the parentheses, this is what we get. Now don't forget, we still have to raise all this to the negative 2 power. So we've got 2 to the negative 2 power. We have x to the negative 9 power raised to the negative 2 power. So that's a power to a power. And so we're going to multiply, we get x to the 18th. And the same thing with the 7 and the negative 2. We have a power to a power, so we're going to multiply and we get y to the negative 14. Now remember what I talked about earlier. We want to move the bases with negative exponents downstairs here. So the x to the 18th is not going anywhere, but we're going to have 2 squared and y to the 14th in the denominator. And of course 2 squared is 4, so that's going to be my final answer there. So number 9 is very similar to number 8, a little bit different, but the same idea. So you may want to try it on your own and then check the video. Let's go ahead and look at the solution here. So first of all, notice the 4. Again, I'm going to simplify inside the parentheses. The 4 in the denominator, I don't have any numbers in the numerator to work with that. So if you could think of it as 1 over 4, but we're just going to leave the 4 alone. We have x to the 4th over x to the negative 4 power. So 4 minus negative 4, when we subtract our exponents here, we're going to get 8. So that's x to the 8th. And then for the y's, we have 2 minus negative 3. So again, be careful here. You're going to get 5. So that's going to be y to the 5th. And remember, that's all to the negative 3 power. So here's a case where it definitely makes sense to flip the fraction and change the sign of our exponent. Notice everything's nice and positive now. So we're going to cube each of our terms. We're going to cube the 4 to the 3rd power, 4 times 4 times 4, that's 64. And x to the 8th to the 3rd power, that's a power to a power. So we'll multiply. And the same thing with the 5 and the 3. All right, again, number 10 is a really good test of your abilities. You may want to try it before watching me do it. All right, let's go ahead and do this problem. So I'm looking at the first fraction, and I've got the 2 powers of a, so I want to simplify that. So notice the 3 doesn't change, but if we do 3 minus 5, we get a to the negative 2 power, and the b to the negative 3 power, that didn't change. This is all to the negative 2 power. On the second the second expression here, I'm going to flip that fraction because there's nothing to simplify inside the parentheses. It'll be 3 over ab cubed to the 3rd power. So now let's apply that negative 2 exponent to the first parenthesis. We got 3 to the negative 2 power. A to the negative 2 power raised to the negative 2 power, when we multiply, right, because it's power to a power, we're going to get a to the 4th. And again, we have a power to a power, so we're going to get b to the 6th, negative 3 times negative 2. And then I'm going to finish that out, and I'm going to multiply by the other. We have 3 cubed. Now be careful, that's 3 times 3 times 3. That's going to be my numerator, 27. We have a cubed in the denominator, nothing to do with that. And then b cubed cubed, so we have a power to a power. So we're going to multiply there, we get b to the 9th. All right, we still have some work to do here. I'm going to go ahead and put a 1 there, and I'm going to move that 3 to the negative 2 power downstairs. So notice the a to the 4th and the b to the 6th, I didn't change that. But 3 squared in the denominator, that would be 9, because I moved the 3 down and I changed the sign of the exponent. 3 squared is 9. And then that's times 27 over a cubed b to the 9th. So in this case, we can do some canceling. If you wanted to, we could multiply everything across and then cancel. I'm just going to go ahead and cancel in this step. So notice 27 over 9 is what we're going to end up with our numbers when we multiply across. 27 divide 9 is 3. We're going to have a to the 4th over a cubed. Well, 4 minus 3, we're going to get an a to the 1st, or just a. And then we have b to the 6th over b to the 9th. 6 minus 9 is negative 3. We get b to the negative 3, and we're going to want to move that base downstairs. So we end up with 3a over b cubed. All right, let's move on to the next page. Actually, that's all I have for this part. Remember what I said in class? We're just getting a head start on assignment 39B, and I was just doing the first page here. The notes are online, so you're welcome to go further if you want. We'll talk about radical expressions, and the relationship between radicals and fractions is exponents. So that's what we'll do next time. So we're going to stop right here.